Hello. Welcome again to another episode on Talk Architecture Podcast, and I'm your host, Naziaty Mohd Yaacob. This podcast is also being video recorded and will be uploaded on YouTube. The topic that I will present today is something that I have done earlier on March 10 for the Institute of Engineers Malaysia. The topic is designing for every citizen, engineering inclusive urban landscapes, and focusing on street environments and public transportation. I would like to give an idea of who I am and where I'm coming from to all. Since 2014, we've conducted research, and in particular on accessible transportation under a Grand Challenge funding as a former academic at University of Malaya. It went on for about 4 years. And then I've also taught, so design elective courses. And then we got another funding to build version number 2, a universal design bus stop under Innovate Fund. And above all, I had been a disability activist until 2024, and now I'm self-employed. So I really would like to go and share this experience and understanding on the ideas on accessible transportation to you all. There are two critical factors that is a theme for the talk, which is focusing on transit points. The main story will be the example of the bus stop designs, which includes pavements and sidewalks and crossings. Another factor that is throughout the talk that is going to be discussed is barrier-free principles, safety, accessibility, and usability of the built environment. This is more or less what it is for today's discussion, where we have an introduction, the main story with regard to the bus stops, and then we're going to the more factual things like where we are stuck in with regard to the Malaysian standards and how our neighboring country Singapore got it right, and some critical dimensions information, and then we conclude. So of course I'm going to start with the introduction, and there's an image of me disembarking from inside the bus onto the road. The interface between the vehicle and the pavement is kind of ajar or far apart, like at least 900 millimeters, but that is not enough to have a proper landing. And the bus driver was assisting me going down where the ramp is now steeper and I need assistance. That person was struggling, and the back of that person is onto the fence. So the fence caught with that person, and we feel a bit uncomfortable with this situation. I felt like I might fall off my wheelchair and it will be a calamity. So these are the details that are not working so much for an accessible transportation system in Malaysia. Another starting point that I have is as an academic that served the University of Malaya for 25 years, I do not have a chance really to use my manual wheelchair independently on the pavements. And there's always discontinuity or something wrong, like no ramp or at the edge, or discontinuity of the pavements in terms of going through them, that I end up sharing the road with motorized vehicles, which is very, very dangerous. And, University Malaya on the right is like a touristy map that could offer a lot more in terms of me enjoying it, going to the lake area or maybe even traveling across to other parts of University Malaya. There are the pain points that others share and in the Facebook, social media. I have my friend Moses Chu talking about showing a illustration or an image taken on a sidewalk where it's about 900 millimeters width, but a tree obstructs much of it, and it's just only 600 millimeters, which is too little for a wheelchair user to pass through. And for him, who is a blind person, there is a lamppost at the end of the tactile guide, which is an obstruction for him to go through. So also a reflection, of course, it's even if it's well designed in this image that was found in an article, is based in Puchong, where you have designated areas with enough width, but it is poorly maintained, broken tiles, and the lady on a motorized wheelchair is not using that sidewalk, but is in fact on the road rather. And this is something which is part of the pain points that we're experiencing. And there's another one where illegal steep structures such as a steel ramp is being used, and there is a good intent to get wheelchair users to go to the many restaurants in this side of the shop houses in Taman Tun Dr. Ismail, Kuala Lumpur. However, it is an illegal structure and it is not according to standard, and it could be hazardous as well. And as you turn around the corner, you can see illegally parked motorbikes on the sidewalk. Although we know there is a lack of continuity with the sidewalk, which is next to the 5-foot way, with a lot of obstruction. It could have been done right so that we can enjoy more the built environment in terms of facilities for us to go around and of ease. So another thing that we learned as well is that even though we built version number 1, a bus stop in front of a residential college 4, the bus is not confident enough. Maybe is the design of the lay-by, maybe is just not knowing to flip down the ramp inside the bus onto the pavement. So we still have this problem of embarking and lack or gaps in the system that is make it inaccessible. So on the left, so we can see that this idea of having the ramp directly go into the road is a poor understanding of what is needed to design a proper bus stop. Although I'm going to show you the latest bus stop from Petaling Jaya later in this presentation. So what are the starting point I'm starting with here in this conversation and what I and others have learned? So in summary, the poor design of the transit points, the interface that is not having a proper way of making it more accessible and safe. No continuity or lack of seamless connectivity. The ramps are steep, if there's any, or there's unsafe, or there's just no ramps. The poor design and build, which is the lack of width or having obstruction on the sidewalks and connectivity. That it is poorly maintained and unsafe pavements, and illegal ramps are not according to standards, and the lack of parking facilities and designated area or lack of enforcement of illegal parking. How do we actually use all this, which we summarize, to actually make it better for ourselves? So here we want to talk about the bus stop design that we were involved with. And this is the main story of the presentation. And I hope that you will learn something from this experience that we had as well. As a researcher, or as an activist, or as someone who's working with the government, if you're an engineer dealing with these issues, this is something that I would really like you to understand. Now, when we look at the whole background of what it is all about, Accessibility can only be achieved with seamless connectivity, that there is no barriers from the point that you start to the point of your to your destination. So between the starting point, there is the means of travel that you need to do. You come from the homes, hostels, flats, apartments, terrace houses, and so on, and you want to work, study, play, eat nice food, meet up friends and families, and travel and be mobile. So you need to either walk or use the pedestrian environment. So either that, you'll be cycling or using public transportation, buses, taxis, or Grab or Uber, door-to-door accessible vans, private. You may be using private vehicles if you have someone to help you with using a car or motorcycle. There are a lot of people who are disabled that use motorcycles that are modified. So apart from using vehicles or a device, you are also needing to use the road, which is the built environment infrastructure. Apart from that, the pedestrian pathways, including transit points, like public transport interfaces, crossings and junctions, and even guardhouses. Then you would reach your destination for work, such as offices and public facilities, parks and gardens for recreation, schools to study, place of worship, to pray, clinic and hospitals to go for treatment, community halls if there's an event, and go to another transit station like um, railway station or other stations like to go and travel. And then you have also other recreational areas such as sports centers. So what is this? This is like everyday thing and something that is we expect to be doing, having to meet people and go about independently. So what is happening here is that when we analyze all this, there is this thing called the first mile and the last mile. After you leave your home, you have to negotiate these crucial transit points of bus stops. When you take the bus, of taxi stops or grab stops, pavements, crossings, and bridges, you have to go through this first mile, and it could be also similar with the last mile. So a local authority officer always talk about these gray areas of development between different owners in which local authorities have the jurisdiction or others have the jurisdiction. It's not only local authority, because we found out that at one point there are 13 different departments and agencies that deal with the street environment. So I will explain about the legislation later. So here we need to understand that also when developers build one building and another building, there is this connection that from one building to another building that needs to be sorted out. Like, for example, you're in an office and you go to a restaurant, in a shopping mall, that area, which could be part of the development by the ownership as well. So who are we talking to when we talk about this? And there are factors to consider. So we need to identify the barriers and challenges every citizen in Malaysian towns and cities face. So these areas in the street environment are the jurisdiction of engineers who uses logical design and knowledge on accessibility and universal design. There are also construction industry players, property consultants, and developers. So there are also local authority and government agency officers. So this knowledge needs to be understood by those who are in charge of these the street environment. So what I'm suggesting is when we look at this, the design approach that we do is a more logical design approach. It is not emotional. It is based on things that has to do with functionality, logical design, and we need to be flexible with what we know based on the context of it. And we're looking at accessibility and standards that are found. And also we could go beyond that with universal design. And then when we talk about the low context specificities, we're looking, of course, we're thinking about how it operates, the construction, but we also look at the site. It could be a different site, even in the same area or neighborhood, which have different dimensions that you could only have replicated based on your prototype of design. So the aesthetics of this bus stop design, for example, will need to be practical and logical. So the universal design bus stop that we did with version 1 in 2019 was funded by um, the deputy vice chancellor using the student affairs funds for disabled friendly facilities. At one time, the deputy vice chancellor was also in charge of the development unit. And so it was opportune that we could build this proof of concept that we designed under the University Malaya Commercialization and Innovation Center, UMCIC, which we as a startup started in 2015. So we had input from wheelchair users and blind person. This is the before picture on the right, top right, where the old bus stop is just a typical bus stop with benches, and that's really it. What we did was we tried to design a bus stop. After going to Singapore and finding a lot of information as well, we designed our own where it is it has all the universal design features, but we learned from it that we need to actually improve on it. The universal design principles that we have are like the low, we use design that provide for low physical effort, which is one of the universal design, yeah. And where the grab bar at the benches is extended out so that we can push ourselves, propel ourselves easily. So we incorporated that. And then there's a free flow of going into the bus, the interface between the bus and in front of the bus stop. Apart from the bollards that's designed well, because you can't have the bus going into the pavement accidentally and hitting people. That's why we need the bollards. Rather than having guardrails, which may impede going in and out of the bus. So we need to be very sure where the entry, disembarkation points are. Yeah, we developed this after we've gone and surveyed a lot of bus stops in Kuala Lumpur as well. And finally, we come to this drawing where we have the idea of a wheelchair user can just be positioned in between the different seating, which is like a square seating where people can face each other, and it could be quite interactive. There are bicycle racks at the back. It's kind of very basic in a way. So in University Malaya, we identified the site with the help of the Deputy Vice Chancellor Office in 2018. We got a mock-up done with people coming in to validate the design in which we're going to be on the there was a mock-up study of the existing bus stop and excuse me, and with and also a blind person as well giving us input. And then we're also thinking about a tactile embossed tactile signage. The tendering started in early 2019. The budget apparently was 87,000. So that's another consideration that we need to move forward, that we need to design something which is cheaper and yet much more useful. So they started work in July 2019, and in September 2019, we did a design appraisal after they built it halfway, in which the ramp was very difficult to negotiate, and we illustrated it to them so that they had to rectify it. So it was uneven, the ramp was uneven. But this is not the ramp going onto the road. It's just part of the pavement. And it is a way, the ramp actually, you can access the ramp from the road, but it's away from the bus stop. In hindsight, that's not the way to do it, to have any ramp near the bus stop going onto the road, because it confuses the whole system of embarking and disembarking and where the landing points are. Those are some things we learned with regard to the bus. So now it's completed here. It's like a beacon at night, hoping that if you're a bit vision impaired, you can find it. But that's not the only issue with regard to blind persons' accessibility to the bus stop. So we learned from that. Yes, we did try to do the tactile information board so that for a blind person to understand what number of buses come at what time. Things may change, so that's why this is not really sustainable. So, in terms of where to wait, we also figured out later that we need to be more precise in giving information how, where for the blind person could embark onto the bus stop. So those are things that we learned. We got feedback from the users and experts. We even had a presentation of the new version number 2, scheme 1, to the Ministry of Transportation offices, APAD, agency for land transport, the housing and local government, Prasarana, a corporation on transportation and service provision, MRT Corp, another one, Kuala Lumpur City Hall, and Rapid KL in July 2020. We managed to get in Innovate funding from the university and design for version 2. We also got feedback from Petaling Jaya with regard to their bus stop, which had Wi-Fi service and recycling bins and bicycle rack. But unfortunately, we don't agree with the ramp going straight to the road. They have benches, which concrete benches, but they have done differently after that, which we will show later. So this is a set of slides, what we presented to Kuala Lumpur City Hall, and I'll talk about how that we happen to be assisting them with version number 2. They were funding the bus stop, but we were given a lot of leeway to give input. But this by chance we were presenting to them this design, also to do with the Grand Challenge research, where it was necessary for us to go and present something that we've done with them. So in October 2020, we presented this. As you can see that in between the bollards, you can have entrance, the front entrance, the indication by the warning tactile below, the L-shaped one later on you shall see. And then you have the middle entrance or the rear entrance where the flip down ramp can go onto the pavement. And the waiting is next to it, denoted by the international access symbol on the floor of the bus stop. So all in all, the University of bus stop that has designed and built in version 1, 2019, has taken into account many factors for blind persons and wheelchair users. However, due to the development of technology, version 2 was designed to include the needs of transportation for more users, including persons with learning disabilities and deaf persons. It took into account several design criteria to make it universal design, robust, modular, low maintenance, and self-sustainable. So we had draft number 1 and finally have draft number 2. So the latest design relook into critical dimensions such as appropriate seating and standing space, street furniture placement, pavement height, and also reconsideration to the needs for ramp. Other design elements include improvement to information board system, solar panel, and advertisement board. So there we have this, the basic modular design, the design criteria, and then what we have identified, the components in detail for the universal design bus stop. What are the basic physical elements? There's a roof, seating area, standing area, bollards, non-slip flooring. It is brushed concrete finish that, from time to time we realize that's the best way for Malaysian implementation, because they can't have concrete slab like in the UK. So they want it to be done quicker. So they have brushed concrete finish with the largest surface area. And then lighting point in the bus stop sign, bicycle rack, bus information board. What are the disabled friendly element? We have designated space for wheelchair user to wait so that the bus driver can identify that a wheelchair user will be going on board, and they could try to go and park as near as possible to the pavement. And then we have the warning tactile for the non-sighted people. The operational element is the real-time bus arrival information board. The self-sustainable element are the solar panel advertisement board. And other elements, the bus lay-by with the bus box outline. And it's very important that they're able to park properly in the lay-by. So this is the plan of it. As you can see, the L-shaped warning tactile. We have also the warning tactile that denotes from the sidewalk approach on the right and the left that you have arrived. And then when you're seating at the bus stop on the left, which is the front of the bus, there's an L-shaped warning tactile with 600 millimeters deep to the edge of the curb, because that's the warning. Warning has to be done much further rather than fall off the curb. And then you can, the non-wheelchair user will enter at that point. The wheelchair user whom the bus driver identified earlier will go into the rear entrance, and it's right next to the the parking area for the wheelchair user when they were waiting. So these are all dimensioned out properly for us to refer to as the module to get the bus stop design for universal design. And we have the roof coverage. We decided not to deal with a roof that is higher than the bus, because you could have a double-decker bus. So you're gonna get wet from the edge of the roof into the entrance anyway. So these are something that the human beings need to deal with it as and when that happens. So this is the roof coverage that helps with being sheltered from rain or sun, and also for waiting. So these are illustrations that show the more detailed design. The height of the bench is not supposed to be like the regular height. It's supposed to be higher so that people don't use it as something that they want to sit longer. So it's just to wait for a while. And later we'll show you what happens with version number 2, where we dealt with vandalism. We dealt with if people want to sleep on it and how we don't get people to sleep on it. So there it is, a seating bench, standing area, disabled persons waiting area, bollards, anti-slip flooring, and the details to it. And also warning tactile, clear panel, solar panel, lighting point, advertisement panel, station signage, and real-time bus arrival. So we have thought about it in terms of, we've showed it to the all the bus companies and also the government in charge of land transport. And even the information board, we considered a QR code for real-time bus information at the lower right-hand corner, at the bottom, for you to get information when you're at the bus stop, and other guides and instruction for different for disabled person to wait. So this is an illustration of how step-by-step journey map using bus stop for the blind user for version number 2, where you have already an access map online or a mobile app for the location and direction to the bus stop. So we would think that Google Map has this information, but later I will describe to you what more information that you need when it comes to a wheelchair user and other users who needs specific information for them to help through the journey. So when a blind person comes, they will identify the bus stop from the warning tactile to arrive at the bus stop. Because the dot type warning tactile is to indicate something's going on in front of you. It could be a crossing, it could be change of levels. So in this case, it is a bus stop. So later you search for the boarding point. So it is standardized, so everybody knows when you use the bus stop that to go to that corner where indicated by the warning tactile. So waiting for the boarding, you will have priority boarding at the designated boarding point, an audio announcement of bus arrival through mobile app or real-time information board from the bus stop itself. So then you board with the assistance of the bus driver. For the wheelchair user, the step-by-step journey map is similar with using your mobile phone, or you could, if you're sighted, you can see the bus stop, obviously, and identify it. And you wait at the designated parking area for your wheelchair. If you're not using a wheelchair, you can sit at a bench. And then when the bus arrives, you go to the waiting to the entrance of the bus, and you'll be assisted during boarding. You'll be given priority boarding with assistance by the bus driver using the rear entrance, and the bus driver will assist wheelchair user first before opening the front entrance for the non-wheelchair users. So you could replicate this prototype to make it longer, a longer version of the bus stop. So we were given the opportunity when a bus stop at Jalan Maarof is going to collapse, or is about to collapse following heavy rain. There was a problem with the whole road had to be going closed for emergency repairs. Kuala Lumpur City Hall did not have a universal design bus stop ready designed. So because we presented it to them earlier in 2020, they decided to work with us. And under the Innovate Fund, we managed to get our designs on board. However, a lot of the designs are there. We worked with them. Part of the funding by Innovate is to get us to supervise every week at least with the contractor that is building it. And we got some good decisions, like access to a car parking area at the side road at the back, which is a designated parking for disabled person. We got the L-shaped tactile warning tactile at the corner. We got the bollards. We got the international access symbol parking area for the wheelchair user. But that's about all that we got. And that's version number 2, where you can see also the bench. We design in the armchair type grab rail so that person with weaker lower limbs can propel themselves easier. And then the bench was kind of inclined, so that it's not really conducive for people to sleep on it. So it's robust in a sense that it's made of stainless steel. So there's a video of this. You can go to my channel, Naziaty Mohd Yaacob, and you could watch it in Malay language. Perhentian bus rekabentuk sejagat versi to Jalan Maarof. So this was fresh when it was built that we had this video taken. And so now we're going into part 3, which is the further stories and the problems that we have in Malaysia, where we are stuck with inaccessibility. So we come to the third segment of this talk, where we're going to look at the situation that I mentioned. Here we have the Malaysian standards 1184 2014, where it is stated that there are human abilities divided into 6 categories: physical disabilities, sight disabilities, learning disabilities, elderly persons, mother with child, and deaf persons. Later on in Malaysia, they added in mental disabilities as well. So when we think about what we're doing, we need to look into also the possibility of people getting disabled later in life, such as the elderly people in Malaysia, 60 years and above, to be projected that the population will be 19.8%, almost 20% by 2040, which means that if you take into consideration the disabled persons population of 16% quoted by World Health Organization, and add it to the 20% of the elderly population, you get 36 of the population in Malaysia by 2040 to be need to have universal design to be incorporated or be, naturally part of the logical design approach. On Universal Design Talk, I have in my channel in YouTube the link I will also have below for you to click on to get some knowledge on Universal Design if you haven't already. And this was a lecture that I recorded for one of the schools of architecture. We know that when we talk about universal design of families, because one family member which needs accessibility, for example, somebody in a wheelchair or somebody using assistive device such as a walking stick and unable to stand for too long, or you have in the family expectant mothers or nursing mothers and people that need little children or young children needing help from their parents, you'd have the need to want to go out together, and there are limited places now to go, and you don't have as much choice as somebody who doesn't need the universal design as much. We have a photograph image of a guy, a person using some sort of a walking aid, or seems to be using a stick as a walking aid with a backpack and having some sort of support at the knee, with a lady, an elderly lady, pushing a trolley going shopping. So independent living is something that is sought after and is being supported by the design of the built environment, obviously. So this is kind of like we need to understand the sentiment and empathy that is needed for us to come up with, or to have when we talk about wanting to design for others who need universal design. So what is the problem with the Malaysian standards at the moment, being that it needs to have revision since 2014? And what is it that we want in terms of how the Malaysian standards could be much more up to date with specification or the guideline that it need to have. So this Malaysian standard is a universal design accessibility in the built environment, second revision. So this Malaysian standard is under the Uniform Building Bylaw 34A of the Street Drainage and Building Act 1974. It's straightforward when you have to deal with inside of the building or designs within a site boundary. But when it comes to areas that are governed by a combination of federal, state, local laws, as we mentioned, the city pavement crossings and bridges. So the direct jurisdiction often fall under the local municipal councils or pihak berkuasa tempatan, PBTs, or the public works department. So the key legislation to govern, the street environment includes the Road Transport Act in 1987 and also the Local Government Act in 1976. So we don't have like, shall we say, a standard for outside of buildings. We used to have, but it wasn't linked to any legislation. So here we have more detail about those three acts. We have Town and Country Planning Act 1976 and Persons with Disabilities Act 2008. That doesn't have much teeth in mandating public facilities to be universal, to have universal access. We always rely on the Streets Drainage and Building Act and Uniform Building Bylaw 34A. If you need to enforce, we can use that act because all the states in Malaysia, excluding Sabah, has gazetted that act since 1999, the earliest being 1991. So therefore, there's a need to incorporate code of practice for access of persons, disabled persons outside buildings, covering footpaths, ramps, and crossings into the MS 1184 from the previous MS 1331, which doesn't fall under any act. They were trying to do it, but there wasn't much in the 2014 revision, so they're trying to incorporate much more. So we again look at the responsibility under those standards, codes, and acts, which lies upon the local municipal councils who are responsible for the maintenance of sidewalks, urban streetlights, and local crossings. And the Public Works Department, which handles major roads, federal roads, and the structural maintenance of bridges. So routine upkeep will be contracted out. And the police force, which enforces traffic regulations regarding crossings and penalties for violating pedestrian rules. So you have the illegal motorcycles comes under the police force jurisdiction, or the local authority traffic control personnel. We also have special jurisdiction for federal territories under the Ministry of Federal Territories, and issues in strata property where, it is clearly that strata property titles, like in condominiums, is kind of difficult to get accessibility done under the strata title property. So therefore we trigger the MS 1184 and UBBL 34A. What we need to consider are that street environment, the pavements, to be wider than just 900 is like for internal corridors, even that small corridors. But we do find sidewalks that are just 900 millimeters. Like for example, in Jalan Tunku Abdul Rahman, because of its heritage area. But there need to be guardrails so that people don't fall off the curb in such a busy road environment. So what is great if we have that buffer of landscape and then we have the inner part of the pavement to be at least 1.5 meters, or the best would be 1.8 meters. As you know, when it's sloping down in the external environment, is the best would be 1:20 gradient. 1:12 is now superseded by 1:14, but it's solely for inside of buildings. So we need to actually have outside of buildings 1:20, which is it's much more easier to negotiate. And the camber going against the slope would be 1:50, because that is also important that we get the right sort of crossfall gradient. In Singapore, the curb height is about 165 to 170 millimeters. In here, we consider centimeters. So I'm going to talk about millimeters now. So we recommend 180 millimeters. If I made a mistake with the meters, millimeters, or centimeters, please excuse me. So from 165 to 170 in Singapore. In Malaysia, we need to go to 180 rather than the proposed, or many in the built environment already 225 millimeters, which makes it kind of like very, very difficult to create ramps at the junction. And there are instances where they actually have a curb, but the pavement are lowered because of wanting to make it more accessible. And you see here on the left, which is if you have a higher step or curb, you would need to have the ramp much longer, because then you could actually use it. If it's lower, then you can have it the ramp shorter. And in the frontage zone for the residential and commercial frontage, there's an attempt with regards to the right side in the image. The commercial frontage area, next to the parking, there is a set of pavement, but often you have meters or you have obstruction on it. So, and it is not really well done in a way, but I'm thinking that how are they going to sort out the lampposts and street furniture and other things so that people can use that much more easily? There are options rather than just the 5-foot way inside that leads to the cafes, sorry, the shops. But in residential areas, there's difficulty in getting proper footpaths, but they had done so in Singapore. And, we can refer to a lot of other standards apart from Malaysian standard, a code on accessibility in Singapore in 2019. I think they revised one earlier, and American Disability, a Discrimination Act, the Disability Discrimination Act and Part M document in the UK, and other guidelines. So Singapore, they look at accessibility compliance based on the code of practice on accessibility for disabled persons per se. But they go beyond. In practice, you need to employ universal design principles. So they look at universal design index as something that is necessary for the aging population policies that they got sorted out, I think by 2030. So they have it in their own development control process, how they integrate universal design index into the construction stages. So, so design decks, you have to consider elderly person, families with young children, expectant and nursing mothers as well. So in shall I say, in a community hall, you need to have breastfeeding facilities, for example, for expectant mothers, and then lots of benches and good lighting for elderly persons, good navigation, and also for families with young children, play area and so on. So those things would get you into the award system for the best building, getting a platinum, or I'm sorry whether they're given platinum, but they get the UNESCO Design Index Award now, and that is a really good thing because it creates a sense that the property consultants own the process and wanting to get it right for the aging population. But the minimum is accessibility, compliance, and in a development or when during the constructional phase, if the local authority find that they're not according to compliance or standards, they could issue a stop work order, or you need to sort it out, and then only you could proceed. So it costs money, and people don't want that to happen. So that is one way of getting people to comply. So in residential areas in Bedok, Singapore, for example, in 2015, at the same time in Singapore, there was a funding of the government budgeted $85 million Singapore to upgrade the pavement and the bus system. And almost all the buses I can use for using a wheelchair. And here we have the government taking over that area, which is not belonging to the owner at all, outside of their gates. That area has been given up to the government to use as access way. And that is protected pathways that allow people to move about in a safe manner. All the manholes and anything to do with street furniture is taken away from that pathway. And the design of the curb could be higher, like you see, with the landscape area. But the one inside does not necessarily have to go high. So also where the drains are away from the paths so that there won't be any flooding in the area. So it's designed in such a way or integrated in such a way that minimum sort of problems or barriers done in Singapore where everybody can go about without having to be on the road with the other vehicles. So in the right of way is given to the pedestrian pathway when it comes to driveways. The concrete surface is built as a clear differentiation between tarmac road surface, continuous usage of the material from the pathway to the top of the driveway. So is the brushed concrete finish, I think here, is the more clear, the more priority is given to that. So depending on the frequency of vehicles coming in and out of the driveways, warning tactiles for the vision impaired persons can be installed for busy driveways. So now when we think about all this, we think about critical dimensions. And I'd like to relate something that I had the opportunity to do an access audit. And I learned that designers, be it engineers, landscape architects, or architects, need to understand about the change of levels and how difficult it is to create ramp system that works. Try to find the level which is have the most traffic or pedestrian traffic. So you begin with that datum, and then you can create the vertical circulation, side vertical circulation that you don't really need to use if you're a wheelchair user. So you can get access to the main circulation area much more easily. So we have known about the path width minimum 1.5 meters, which allows if you have two wheelchairs passing 750 millimeters. But as we go along in this day and age, having scooter and personal mobility device that takes even 1 meter point. So, or 900 to 1 meter. So even you have wider area is much better, like 1.8 to 2.1. For the ramp slope, the 114 minimum, I just minimum, for inside a building, we can use it for outside, but it's not to be done all the time. The best is 120 gradient for external area. The tactile, um, for to the edge of the curb or to the edge of the change of levels, it's better to have it 600 millimeters deep, even having a double set of tactile guide, which is the warning tactile. And the 5 millimeters high conical dots, it was originally conical rather than truncated. So in this instance, the reason for the conical dots is so that to assist people who are diabetic, who cannot feel the soles of their feet so much, to have these conical dots. But more and more, there is some sort of, shall we say, compensation, not compensation, that truncated dots are being acceptable, especially inside a building. The bench, you have the 450 millimeter seat everywhere in the shopping mall, for example, would help with a grab rail armrest to propel yourself out of the seat if you have weak lower limbs. So that is common for elderly persons. We look at the ending of this chat that we're having here. When we look at the built environment and try to find out how accessible it is, you can do a bit of research. You can use the Google Earth and Street View audit, which is kind of free, or you can go and audit with using a measuring tape, a laser measurer, or a slope app. Or you could do a proper study using GIS layer for accessibility gaps. And I had met people who on x.com, sorry, who is like a 1 or 2 person activist going around auditing whether the lifts are broken for all the rail stations, MRT, LRT in Kuala Lumpur. He did it in a couple of days and shared that information with Rapid KL. And it was interesting because they did it, but they weren't doing it for disabled person. But that information is important for me to actually use when I need to find out whether something a station is accessible or not. One much more systematic way is it is useful for the user, like for myself, when I'm talking about myself now, where I need an access guide or navigation. And in London, you have City Mapper for access guide. For navigating London, City Mapper is generally superior for public transport, providing more precise real-time and detailed route options, including which carriage to board, compared to Google Maps, which Prasarana was talking about that they would rely on. And I don't find much information for access guide in Google Maps because it's just better for walking or driving and find local businesses and amenities. But for access guide, you need a much better mapping and guidance. So a bit on access audits. After Jim Harrison, access audit could either be using a checklist based on the standards for direct observation technique, or you can interview disabled persons or users, or you yourself could do a walkthrough of the area and determine yourself how accessible it is. So access audit could be a combination of all three or either or. And it could also come into designing. If you're a designer, you can actually, from the access audit, design a solution. So we were talking to engineers and we want to underline that we need to look at it system-wise or system thinking. For version number 3, we can have a small budget and do one that is much more precise in how in the local context and whatever apps or whatever things that we have at the moment for public transportation. And once we get it right the first time, it's easier to replicate the prototype. And for us who are activists and researchers, we could collaborate and work with all agencies and departments. And we would be also the one trying to validate the design with feedback from the users. So, we have an interesting thing here where I would like to go and use this bus stop, which is on Jalan 17/1. But if I were to go onto the platform in the waiting area, I need to negotiate two ramps, and I'm not sure whether they're accessible. And if I go to the one on the pavement that has a tactile guide on it to board onto the bus, will the bus driver assist me? Because it seems like there are two platforms or two different levels of different things. I'd assume that because it's Jalan 17/1 is less busier than the main road. So when we're going back to this interface between the vehicles and the bus stop and how to embark and disembark in a safe manner, and why are designs of bus stops different in different areas in Kuala Lumpur, Petaling Jaya, or Klang Valley area. So we need to have a much more safer way of doing this. This is for a much busier road. And I'm glad that there is no step ramp going down to the road. And I would assume that the bus would know how to pick me. But there is this columns in the front, which doesn't allow a free flow. And the bus would need to get it right the first time round, how for me to enter and for others to enter. So I was kind of confused where exactly the front entry is for this particular bus stop. So for the engineers out there, we need to pick a street, measure it, and propose version 3, and I will assist with this. And I have my contacts here if you would like to do it. And we've done this before with the DBKL, and we could do with all local authorities. Thank you very much. A bit of reference there.